Let's tackle showing the number of completed subnodes. That's this task right here. The concept is pretty simple. If the tree has children, count the number of children whose completed property is set to true. The label will no longer be referring to the tree property directly if the tree has children. Let's implement this in the constructor of our TaskQueue item component.cpp file. Let's do this before all of our label stuff. Let's remove this label refer to. And we will do if tree.getNum children is greater than 0. We're going to do one thing. Otherwise, we'll do our refer to thing that we did before. Label.get text value dot refer to tree.get property. Property is value, and we want the name property and that owner.undo manager. Okay, in here, we'll build a string to display which includes the number completed versus the num total. So we'll need to come up with a get num completed function that makes that little ending bit. So let's declare that first, and then we'll write it. So we'll just stick this at the end. String get num completed. And now we can do label.set text tree, read the property, to string, plus give ourselves a space, plus, and we'll call that get num completed function. And don't send a notification for when that thing gets sent. And let's stub out the num completed down here at the bottom. String TaskQueue item component get num completed, and we should only call this if we have kids. So jassert tree.get num children is greater than 0. And let's see, only call this if the tree has children. And for right now, we'll just return a blank return 0 divided by 0, something like that. We'll just eventually we'll write something that returns the correct thing. But for right now, this is what we'll see. Since we are no longer referring to the tree's property directly, we need to update the tree property whenever we change the label text. So we'll do label.onTextChange equals, and this is where we need to do tree.set property name label.getText. Get text, there it is. And then now we want the undo manager. Owner.getUndoManager. Like that. So whenever we have children, we need to manually set that tree property. Otherwise, we will just refer to it, and every time the label is edited, it's going to refer to it directly. Okay, so changing the text is going to trigger this callback here. So this is a chance for us to update the label text and add the num completed versus the total count to the label text. So we can say, let's add some curly braces here. So in addition to repainting, which actually we don't really need anymore because we're not painting anything, we can do if identifier equals identifier name. If it's this thing, then we can update our, we can label.set text with that fancy string. So we can just copy this. All right, we've got our code in place. Let's build, run, and test it out, and add some nodes and see what happens. Okay, so first of all, the topmost node's text was not updated. And we should be seeing a, this thing here, we should be seeing a 0/0 at the end of TaskQueue tree. And my guess is that it's because the topmost tree is not having any children. It's not being recreated from scratch, and we can verify this if we check this address. It's E0E80. Let's see what happens here. It's the same one here. There's only task 0 and task 1 are children, and then here, so that's also 0E80. Same for here, 0E80. Okay, yeah, so that makes sense. It's not going to recreate this tree, which means it's not going to call this constructor, which is what populates the tree if it has more than one child. Okay, let's see what happens if we drag and drop. Dragging and dropping does update nodes that are created from scratch correctly. So we probably need to implement the value tree listener callbacks that deal with children being removed. Now, just for a minute, I want to talk about this don't send notifications with regard to this infinite loop problem. Let me rerun this and we'll check some stuff out. So if we rerun this, and if I add a couple tasks, and I'm going to rename one of them, I'll just do this edit. See what it does. Okay, it hits the jassert. For some reason that got called. Why did this get called? Let's see if we can figure that out. Where's a member function of our class? Value tree property changed. Okay. All right, so this is why that got called. Why did value tree property changed get called? That was called because, if we expand this a little bit, we can see juice value. Okay, label update text from text editor contents. All right, text editor key return pressed. This comes back to the fact that if our label has no children, we are referring to the value tree property, which means whenever we update the label's text, it's going to update this property, and updating the property is going to call label.setText. So let's just press play and see what happens if we get some infinite recursion. Okay, let's see. This is at 58 down here. That's what our call stack starts at, 58. Let's see how big that'll grow. I'll just push this a couple times. Oh, it's much bigger than 58. It's 118. So this is just going to keep going. Okay, so that's an infinite recursion problem right there that we'll need to deal with. And what about this don't send notification? Does that do anything? Let's change this to send notification. Well, our way to test will be to do send notification. And then we'll also change this one down here to send notification. And we will run it. And our goal is to edit the text for a node that has children and see if we end up with some kind of infinite recursion. So edit. This node has children. So we know it's going to call this on text change. Okay. Oh, spinning wheel. So it's doing something. Oh, look at that. There it goes. It froze. 82% or 82 megabytes of memory. That became really large. Look how long our call tree became. That's massive. That's some infinite recursion. Let's see what happens if we abort this, if we go back and change this to don't send notification if we still have that problem. Don't send notification. Let's try that one more time. We'll try the exact same thing and we'll see if we run into that same problem. All right, add a couple nodes, drag and drop, edit the node with children. Are we good? We're good. Look at that. It totally skipped a lot of this. So that's fantastic. Okay, very cool. All right, so we got to see a glimpse of this infinite recursion loop that can happen because of these value tree listener callbacks, and like if we're referring to something or if we're not, and if we're sending a notification when the text gets changed versus if we're not sending a notification. If we actually move into this setText function, we can see that this is where the text value actually gets changed, and when the text value is assigned, it's a value class, and we look for this operator equals. That'll be over here or over here, this guy. We can see that we get like value, set new value, and then inside of that, value tree property value source set value. It's something, it's in like one of these. Okay, tree.set property, right? And then under tree.set property excluding listener. If we follow this some more, object set property, then this is going to lead to a bunch of like send property changed message excluding. And inside of here we have the actual like call to the value tree property changed, where it's going to do this for every tree, every listener of that particular tree. So it gets pretty deep pretty quickly, and that's part of the reason that there's a lot of infinite recursion that you have to watch out for with this value tree stuff.